lecture 4 of 5, which is we continuing the fourth subtopic 5.4, which is the application of vectors in geometric. So for this lecture, we are going to focus on the finding the equation of a plane. Equation of a plane. So let's say this is our plane. So what we have on the plane is a fixed point A, and the normal vector passes through A on the plane. This normal vector is a vector that is 90 degree from the plane, and then the point R, which are located on any of the plane, any places of the plane. Okay, suppose a plane is a space has normal vector n, which is equal to ai plus bj plus ck, and that it passes through the fixed point A. So this normal are passing through the A, and r is equal to x, y, z is any point on the plane. Therefore, AR is perpendicular to n. So what do we know about perpendicular? If we find the scalar product between a perpendicular vector, it is equal to 0. That's why we can say that AR dot n is equal to 0. Okay, because AR is the line or direction on the plane, and normal is a vector that is perpendicular to the plane. So because AR and AR perpendicular to n, then the dot product between these two vectors equal to 0. What is AR? AR is OR minus OA. And then we know that OR is the position vector R, and OA is a position vector of A. So R minus A dot n is equal to 0 by applying the properties of dot product. So we will have Rn minus An, R dot n minus A dot n is equal to 0, means we can rewrite as R dot n is equal to A dot n. If you want to remember easily, you can just remember roti none. So we have roti, we have none. Okay, this is vector equation of a plane. And then we also can rewrite this vector equation in another form. How? We know that R is a vector of x, y, and z, right? And then normal is a vector of A, I, B, J plus C, K. So we can rewrite everything into a column matrix or column vector, which is equal to x, y, z dot A, B, C equal to the fixed point A, which is x1, y1, z1 dot A, B, C. So the left hand side we cannot find the value because this x, y, z is unknown. It will be any point on the plane. But on the right side we can calculate the value. So what we will have is ax plus by plus cz on the left side, and the right side will be a constant, a value d. This is the Cartesian equation of the plane. Finding equation of the plane. So the equation of a plane require a fixed point on the plane and its normal vector. Means that the normal vector must pass through the fixed point. Remember. Okay, let's do example 1. Find the vector equation of the plane with normal vector I plus 2j plus 3k and containing point -1, 2, 4. So now we have a vector, normal vector of the plane. So we have already the n vector, and then it said that the plane contain the point of -1, 2, and 4. So this is a position vector, which is the fixed point on the plane, which is the vector A. So how to find the equation of the plane? So we write down the n and write down the vector A and substitute into the roti nine. So what is our roti nine? R dot n equal to A dot n. So what is R? R is the points on the plane, and then now n is equal to I plus 2j plus 3k, and the right side will have -I plus 2j plus 4k as the fixed point of point A and point of vector A, and then the normal, which is equal to I plus 2j plus 3k. So the right side we can calculate because it's just a dot product between two vectors. So we will have a constant on the right side. So r dot I plus 2j plus 3k is equal to 15. So this is the vector equation. If they ask you to find the other form of vector equation, then you have to write down. And then, example 2. Find the Cartesian equation of the plane passes through -5, 1, 2 and perpendicular to line R equal to 2i plus 2j minus 4k plus t multiplied with 5i minus 3j plus 7k. So, we have the plane that contain a fixed point of -5, 1, 2. And then, this plane is perpendicular to line R equal to ... So where is the line? So line, it can be here. So this is the line. And the line is perpendicular to the plane. So what we can say about the line? So the direction of the line is the normal of the perpendicular of the plane. Why? Normal is the direction that is perpendicular, direction vector that is perpendicular to the plane. So we can take the direction vector of the line as the normal. So now we have this plane and then the line perpendicular, and then we know the direction is represented by V, which is 5i minus 3j plus 7k, and then we can use this V as the normal vector. Okay, and then we can just replace everything into the equation of vector, which is r dot n equal to a dot n. So on the left side we have ax plus by plus cz. So what is a? A is the values from the normal, which is equal to 5, -3 and +7. And the right side we will have a1a plus a2a plus a2b plus a3c. So a1 here is -1, -5, and then 1, and then 2, and then we have the n, which is equal to 5, -7 and +7. So calculate on the right side to get the value of d, which is equal to -14. This is for the Cartesian equation. If you don't remember the Cartesian equation, we can write it from the vector equation, which is what is the r? X, y, z. What is the n? 5, -3, 7 equal to what is the a, which is equal to -5, 1, 2, and then dot product with n, which is 5, -3, 7. So you get the same answer lah. 5x minus 3y plus 7z equal to -25 minus 3 plus 14, which is equal to -14. Okay. Example 3. Given the points of A, B and C, find the equation of the plane ABC in the Cartesian form. So what do you understand about this situation? So the equation of the plane ABC means that the point ABC is on the plane. So we have A, we have B, we have C here. So how do we get the equation of the plane? We need the position vector, a fixed point on the plane. So it can be either A, B and C. These 3 points is the position vector or the fixed point on the plane. But how about the n? What is n? N is the perpendicular vector from the plane. So how do we get perpendicular vector? We can find by crossing between two vectors on the plane. Right? So if we have two vectors on the plane, we cross it. So what we will have? We have the vector that is perpendicular to the plane. So how do we get these two vector A and B? So we can find the vector, it's either AB cross AC. So it must starting from the same point to get the vector. So this is AB cross AC. Or you also can take BA cross BC or CA cross CB. Okay, so to find the normal vector, okay, this is the same. So let me clear off. So this is the plane. Now we have the point A, B and C. So we have AB and AC. So both are vector from the same point A. So we will have a normal that is passing through the point A. So we just have to cross AB and AC. So what is AB? AB is OB minus OA. So OB equal to 4 negative 1 2. OA equal to I plus 3j plus k. So minus OB to OA. So we get 3i minus 4j plus k for AB. And then how about AC? So it will be OC minus OA. So what is OC? 1201. And then OA is equal to 131. So minus OC to OA. So we get 11i minus 3j. So we have these two vectors already. To find the normal, we have to cross between these two vector AB and AC. So apply the formula. So we have IJK, and then second row is the vector AB, which is 3, 1, negative 4, 1. And the third row is vector AC, which is 11, minus 3 and 0. So apply the formula. We have the normal equal to 3i plus 11j plus 35k. And the next step, we just have to replace the vector n with the normal we've got from above, and then the vector A equal to the point A, position vector of A, which is I plus 3j plus k. So the Cartesian equation, you can rewrite it from the vector equation, or you can directly substitute into the Cartesian equation, which is ax plus by plus ck equal to a1a plus a2b plus a3c. Okay, so we have the value of D on the right side equal to 71. Okay, so that's for the, if we have 3 points on the plane. Example 4. Find the Cartesian equation of the plane passes through A, 1, negative 1, 3 and perpendicular to both plane x minus y plus 2z equal to 3 and 2x plus y minus z equal to 3. So how do we sketch this plane? So it passes through point A, 1, negative 1, 3. Means that A is the fixed point on the plane. And then this plane is also perpendicular to both plane. So how can we sketch this plane? Okay, if the plane is perpendicular to those two planes, let's say we have these two planes, right? These two planes has their own normal vector. Okay, so to find the vector that is perpendicular to both vector, so we have to find the cross product between these two normal of the two plane, n1 and n2. Okay, so we have to find the normal of the plane by finding the cross product between these two planes given. So n1 and n2 from the line 1, this one is equal to 1i plus minus 1j plus 2k. And then for this one, the normal is equal to 2i plus j minus k. Okay, so cross product between these two vector, we have ijk of 1, negative 1 plus and 2, and then for the second normal is 2, 1 and negative 1. And then calculate, we will have negative I plus 5j plus 3k as the normal of the plane we want to find. And then because we know the position vector already, which is the A, so we just substitute the value of A, B, C and A1, B1, A1, A1, A2, A3. Okay, so we have the negative x plus 5y plus 3z because the normal is negative 1, 5 and 3. And then here is negative 1 multiplied with the position vector 1, negative 1, 3. So we have the result for D is equal to 3. So this is the Cartesian equation of the plane. Easy, right? Example 5. Find the vector equation of the plane that contain 2, -1, 3. Okay, so 2, -1, 3 is the position vector A and is parallel to xy axis. For question A, parallel to xy axis, xy plane. So what do you think about xy plane? So we have x-axis, y-axis. So xy plane is here. Means that, what do we have? We don't have value for z. So what is the normal of this plane, xy plane? The normal should be parallel to z-axis. So how do we write the normal here? So for the question A, the normal should be k only, 1k, a constant 1k. Why? Because it's parallel to the z-axis. Okay, the value of z is none, so it's going up, the normal going up, which is parallel to x-axis. So the normal is equal to k. So just substitute the normal and a into the formula of the vector equation. So we have r dot n equal to a dot n. So xyz, or r dot k equal to 2i minus j plus 3k dot k. So what do we have on the left side? We have r dot k equal to, on the right side is, everything is 0 for I and j except for k, which is 3 multiplied by 1. So r dot k equal to 3. Okay, so how about B? So what is the question asked you to find? So for question B, they said that, what is the question asked you? The plane is parallel to the plane with equation 3x minus y plus z equal to 2. So it's parallel to this plane with the normal of 3i minus j plus k. Okay, this is normal. Means that the new plane that from the question is having a normal that is parallel to the plane. Okay, means that we can borrow the normal from the plane given. Okay, so for question B, what you need to do is just putting the normal the same as the normal given from the plane given, which is 3i minus j plus k. So the vector equation, just replace the vector a and n into the vector equation. So we have r dot n, which is 3i minus j plus k equal to a dot n. So 2i minus j plus 3k multiply dot beats 3i minus j plus k. So what do we have on the right side? We have 6 plus 1 plus 3. So equal to 10. So r dot 3i minus j plus k is equal to 10. Example 6. Okay, so given the point P, the straight line L, find a Cartesian equation of the plane containing the point P and a straight line L. So we have point P on the plane, and then we also have the straight line L on the plane. Okay, what do you know from the L? Yes, L has a fixed point. They are fixed point A and also the direction vector. So which one is important? Both are important. Why? Because from the point A, we can find the direction vector to P. And we have also the direction vector V, which is passing through the A. So if we cross A to P and direction vector V, then we can find the normal vector of the plane. So what we need to do is to find the point Q inside the line. So what do we have? The point Q here is the values on the numerator. Okay, so we have here, it should be x minus a, y minus b, z minus c. So we have -2, 0 and -1 as the point on the line and also on the plane. And then we have P, which is -4, 2 and -3. So what we need to do is to find PQ or QP. So if you find PQ, what do we have? So it's the same lah. So PQ we cross here kan. So PQ is equal to OQ minus OP. So we have negative 2I minus K minus the OP, which is negative 4I plus 2J minus 3K. So we have 2I minus 2J plus 2K. Okay, and then we know the direction vector is going here. So we can we can use the direction vector to find the normal. How? PQ crossing with the V. So the normal is equal to V cross with the PQ, or PQ cross with the V. So it will be the same lah, because the difference is only the direction up or above, up or down. So finding the cross product between these two vectors, so we have I, J, K, and then vector V equal to 4, negative 3, 5, and vector PQ equal to 2, negative 2, 2. So finding by using the formula, we will have 4I plus 2J minus 2K as the normal, and we can take point Q. Okay, why? Because it passing through point Q for both PQ and the direction vector V. Okay, what is point Q? Our point Q is negative 4, 2, and negative 3 with a normal of 4, 2, and negative 2. So the Cartesian is equal to, yes, 4x plus 2y minus 2z equal to negative 6. Okay, so we can simplify this equation by dividing by 2. So we have 2x plus y minus z equal to negative 3. So that's all for lecture 4. So I hope you can try the equation. Okay. Okay, thank you, class.